Hello everyone, I am Shamesra Senapati, Assistant Professor of Civil Engineering at Vedang Institute of Technology. In our previous classes, we have started our solving our cantilever beam with point load, and in this class we will solve a cantilever beam with one point load at the end support, and here a UDL is there. So, let us solve it. Before solving this numerical, we know that cantilever beam, here AB is the cantilever beam, and we know cantilever beam is supported at one end. So, here the fixed support is at A point, and at point B we are having 2 kilonewton point load, and C to D span is 2 meter. Okay. So, in your general examinations, first thing we have to do is write about the given data. Okay. So, we know the total span, that is L, equals to 4 meter here, and the UDL is CD, that is what, 4 kilonewton per meter. Again the point load we are having at B, that will be 2 kilonewton. Okay. Point load at end will be 2 kilonewton. These are the data we have, and from this data we will solve this numerical, and we will draw the shear force and bending moment diagram. So, first thing we need to do, we need to choose from which end we will start the numerical. So, remember, if we are having the cantilever beam, let us always start from the opposite end of the fixed support. Okay. Here at point A we are having the fixed support. So, we will always solve from point B. So, let us first calculate shear force. Calculate shear force. So, first thing, shear force at point B. Calculation of shear force is what? The calculation of forces. So, shear force at point B will be 2 kilonewton. Okay. Next we will find out that shear force at point C. So, it will be the similar, because you can see up to this, here at B we are having 2 kilonewton, but up to this we have not any load. So, at point C we will have 2 kilonewton of load. Okay. Next, shear force at point D. So, here we will add that the 2 kilonewton load of point load, and plus you can see this UDL, uniformly distributed load, is 4 kilonewton per meter. So, 4 kilonewton will apply all over the 2 meters. So, let us multiply 4 into 2. Here you are having 10 kilonewton of load, right. Next, shear force at point A. So, shear force at point A, you can see after this D we are not having any other forces. So, shear force at point A will be the same, that is 10 kilonewton. Okay. So, we have the shear force values here at different points. So, let us draw the shear force diagram. So, shear force diagrams will be these points at point A, B, C and D. Okay. So, here you have your shear force diagram. You can see at point B we are having 2 meter, sorry 2 kilonewton. Okay. Again shear force at C, nothing but same 2 kilonewton. and here at point D we are having 10 kilo Newton of load. Similarly, at point A 10 kilo Newton of load. We know that in case of point load and UDL, we will have the linear diagram in case of shear force diagram. So, here it is your shear force diagram, and let us join this with linear. So, just we will draw the lines, this to this. Okay. Here this is your positive shear force diagram. If anyone asks you like what part is your shear force diagram, you can show them this. This to this is your SFD. Okay. Now we have the SFD. So let us calculate what? Bending moment. We know that calculation of bending moment is nothing but what? Just multiplication of forces with the distance, right. So, calculation of bending moment. So, how to calculate? First we will calculate from point B. So, at point B you can see there is, if we are calculating from this point, so this point to this point distance is 0. So, you can write here that bending moment at B will be 2 multiply with 0 distance, that will be 0 kilonewton into meter. And again bending moment at C, just multiply 2 kilonewton with 1 meter of distance. So, we will have 2 kilonewton into meter. Again bending moment at D. So, it will be what? This 2 kilonewton load will be multiplied with this distance. So, 2 multiply with 3. Okay. We need to remember as load are in negative. So, we will have the negative bending moment values. So, here minus 2 into 3, again minus 4 into 2, that will be multiplied with 2 by 2. Okay. So, here you will have minus 6 minus 8, that will be minus 14 kilonewton into meter, right. Now, bending moment at point A. So, similarly the 2 kilonewton point load will be multiplied with the whole distance, that will be here 4 meter. So, minus of 2 into 4, again minus of this 4 will be multiplied with 2 into 2 by 2 plus 1, right. So, here you will have the answer as minus 8 minus, here 1 plus 1 as 2, 2 into 2, 4 into 4, 4 into 4, 16, minus 8 minus 16, you will have minus 24 kilonewton into meter. Okay. So, here at point A you will have bending moment as minus 24 kilonewton into meter. Now, we have the all the bending moment values at different points. So, let us draw the bending moment diagram. That will be okay. You can see the values are in negative sign. So, we will have the bending moment diagram in negative way. So, here you will have 0 kilonewton into meter. Next is your minus 2 kilonewton into meter. Again here minus 14 kilonewton into meter, and last is your minus 24 kilonewton into meter. So, as we know from before previous classes, like in case of UDL and cantilever beam, we will have the diagram in parabolic, okay. But in case of point load, we will have linear diagram. So, remember, here to here you will join in a straight line, okay. This to this will be a straight line, but these to this will be little bit parabolic like this, okay. And again, as here we have UDL, so it will be like also this parabolic, okay. Here it is your negative bending moment diagram. Bending moment part is this much, okay. So, here you have the shear force diagram and bending moment diagram for UDL and point load. In this class, we have discussed the calculation of shear force and bending moment of two types of load in case of cantilever beam, that is UDL and point load. So, in our next classes we will solve, we will put and more types of loads, and we will solve in case of cantilever beam. So, you need to stay tuned. Thank you so much.